Hello everybody and welcome to our lesson on section 15D, the quotient rule. So just like the product rule, it involves taking several derivatives and multiplying them together. Doing the quotient rule involves taking several derivatives and dividing them. So the quotient rule states if I have a function divided by another function, then the derivative would be the derivative of the numerator times the denominator as is minus the derivative of the denominator times the numerator as is, all over the denominator as is squared. Okay, so for example, if we want to differentiate this function, we have a quadratic function over a cubic function. We would start by taking the derivative of the numerator times the denominator as is, minus the derivative of the denominator times the numerator as is, all over the denominator squared. Okay, and just notice I'm using this prime notation to indicate what I'm going to do, but haven't done yet. Now I'm going to go ahead and take that derivative. That's going to give me 2x plus 2 times x cubed plus 1. This is going to give me 3x squared plus 0 times x squared plus 2x minus 3, all over x cubed plus 1 all squared. And at this point, I don't have any common factors that I can factor out, so I'm going to leave it in this form. I'm not going to do anything else. As we get better at calculus, we'll develop a little bit of finesse and know how to simplify things a bit better. Right now, that is good enough. Okay. For this example, we again have a function divided by a function, and we need to find the value of the gradient of the tangent, so the value of the slope of the tangent when x equals 4. In other words, find the derivative and then evaluate at x equals 4. So if I want to find the derivative, notice I'm using the dy by dx notation here. I need to take the derivative of root x, the numerator, times the denominator as is, minus the derivative of the denominator, which was 1 minus 2x squared, times the numerator as is, divided by the denominator squared. Don't forget that it was already squared, so I have to square it again. Okay, so the derivative of root x is 1 over 2 root x. You can convert it to exponential form and evaluate it and apply the derivative rules. This is just kind of a shortcut. And the derivative of 1 minus 2x squared, I have to apply the chain rule, so I drop that 2. I keep the base, reduce the exponent by 1, then take the derivative of the inside part, which was negative 2, and multiply that by the original numerator, which was root x. And then I square the denominator and get 1 minus 2x to the fourth. Okay, now here, because I have a denominator in my denominator, I need to tidy this up a bit. So I multiply by 2 over root x times 2 over root x to find a common denominator. Okay, and sometimes it's easier to write this with a dividing sign when we start to have lots of lines and lots of fractions. What I notice is that I get this 1 minus 2x squared over here and a 1 minus 2x. I can common factor that out from these terms, leaving me with 1 minus 2x from the first term and 8x from the second term, and that can cancel with one of my terms over here. Okay, remember that when I'm dividing by a fraction, I can always rewrite it in reciprocal form. And I'm finally left with this. Okay. Now, notice that if I want to simplify it that far, I don't necessarily have to, especially if you're trying to find the gradient of the tangent. Remember that my original question was to figure out what it was when x equals 4. I could have done that over here without simplifying it so much. I just want to show you how that works. But if I do apply that x equals 4, and this is how I would write it, the big line, x equals 4, that indicates evaluate this derivative at x equals 4, I get the fraction negative 25 over 1,372.